Hello, my name is Jongson Park, working in Greece, which is the NMI of South Korea. Today, I'm going to present about the data structure in DCC as a new metadata format. Although now I am working for quality management section since year 2001, I have a master's degree in library science and have worked in Greece library for several years. So I have reviewed the data structure as a former librarian. The DCC has a structured data description scheme that includes all the essential data elements required by the traditional calibration certificates, as well as new data elements for the distribution and utilization of the calibration certificate. The technical source of this structured data is the library's catalog system. The cataloging for the library materials, which has been handed down for thousands of years, became a college curriculum in the 20th century. In particular, Mark was born with the advent of the computer in 1960s, and in the 1990s, new cataloging standards such as Dublin Core emerged due to the diversification of media. This presentation compares the data structure of the currently developed DCC in PTB with the data structure already being utilized in the library. Metadata has various definitions. First definition you may be familiar with is data about data. It's simple, but it's not clear enough. The other definitions are structured data description for information resources, standardized descriptive information for resources, a means by which the complexity of an object is presented in a simpler form, and the most recent one I found is a statement about a potentially informative object. The librarians have been in the business of describing things for more than 2,000 years, and they have inevitably learned a thing or two. The discipline of library science has given the rest of the world a lot of insight into how to describe things effectively. We have to thank to the librarians working out principle of descriptions. It's now possible for anyone to apply those principles to anything that needs to be described. Furthermore, once the database was invented and it became possible to store structured data, it also became possible for anyone to create and maintain metadata electronically. The formats and tools for description have evolved from legacy library card cataloging to current Dublin Core. Many of you have seen this shape of the cataloging drawers and cataloging card inside them. There are many elements like title, author, publication year, publisher, physical description, ISBN, and call number, which led us to find the book on shelves. Those elements are placed following AACR2, which stands for Anglo-American Cataloging Rule 2. This is somewhat old standard format for metadata. At that time, it was focused on books. In 1960s, with the advent of the library automation, that includes storing library-related data in computer to find information efficiently. new data standard format for metadata is necessary. So machine-readable cataloging format developed by the Library Congress of the United States was introduced. It was more complex than before, since computer can handle more than 100 elements easily and speedily. In 1995, the NCSA and OCLC hosted a workshop in Dublin, Ohio, to discuss metadata for the web. The workshop was convened to advance the state of the art in the development of the resource description records for networked electronic information objects. Thus, one of the goals of the workshop was to reach consensus on a core set of metadata elements to describe networked resources. That's why Dublin Core was developed and now is adopted by ISO standard. Dublin Core is the most general and popular metadata format for online and offline resources in these days. And it features simplicity, generalness, extensivity, globalness, and is consisting of 15 general elements. These are comprehensive definition of the 15 elements which can handle all the information of online and offline resources. And these are examples of each element. For the categories of metadata in general, metadata is not used to capture subjective interpretation of the resources, such as relevance, but rather to capture objective features of resources, such as descriptions. Resources discovery relies on good metadata like this. If you were to go to a library to find biography of Isaac Newton, the success of your search depends on the records for one or more resources containing the text Isaac Newton in the subject field, and some indication that a book is a biography. To use our map metaphor, the simplified representation of information objects that are contained in the catalog must include data that will help you discover resources that you might find relevant. This type of metadata is called descriptive metadata, but it's not the only one type there is. In fact, there are several categories of metadata. Administrative metadata provides information about the origin and maintenance of an object. For example, a photograph might have been digitized using a specific type of scanner at a particular resolution and might have some copyright restriction associated with it. Finally, use metadata provides information about how an object has been used. For example, the publisher of an electronic book might track how many downloads the book has received, on what dates, and profile data about the users who downloaded it. There are also many types of metadata for the purpose of resources in many areas. For educational purpose, many formats are already developed like DC education, LOM, GEM metadata, and so on. For cyber and electronic government, there are formats like GILS, AGLS, EGMS, Danish Dublin Core, and so on. For archiving purpose, there are already international standards like ISO 15489, ISO 23081, etc. For art, you can find formats like CDWA, VLA core categories, VADS, etc. For ebook, there are OEBPS, AAP, ZEPAX, EBKS, and EPUB. For the news information, there are newsagent and newsml, etc. As you can see, in some area, if they produce quite a lot of resources, then there are some standard format. So for the calibration certificate, it is assumed that there may be more than 100 millions of certificates issued a year in the world. So it's time for us to have our metadata format. Let's get into the topic of structure in DCC. As you see in other fundamental presentation on DCC in this conference, this is structure as a hierarchy from 4 main elements, which are administrative data, measurement result, comments, and documents. Under those categories, there are many sub-elements. If we compare these two structures, DCC and Dublin Core, there are 10 elements matching each other, and the rest 5 elements are not. Some elements in Dublin Core like type, format, source, coverage, and rights are not corresponding to the elements in DCC. I told you in previous slide that there are 3 types of metadata: descriptive, administrative, and use metadata. In data structure in DCC, we can find the administrative metadata function in administrative data section and descriptive metadata function in measurement result section. There is no function for use metadata. It does not mean that some specific metadata format have to have those 3 functions. As a conclusion, at the first time, an idea to compare standard metadata format, such as Dublin Core, with this DCC structure being developed in PTB, is come from that a book can be regarded as the copy of calibration certificate as a resource. The both formats have a typical metadata structure. However, there are one big difference between them. Usually, general metadata describes some essential information of a resource, but metadata for DCC is a resource itself. It means that we can make a calibration certificate in full using metadata for DCC. So DCC structure is a new type of metadata that has resource itself and can be hardly found in all other types of metadata format in various areas. DCC has a new type of metadata structure. Other insight I found in this comparison study is that some elements for use metadata might be added in DCC structure. As you already know, main reason for DCC development is that distribution of the calibration certificate electronically and applied it to measuring instruments, which means providing meteorological traceability. So some kind of elements for use metadata, such as number of usage of the DCC, what date and profile data about the sun instrument, which are calibrated by the mother instrument. Those data might be open, usable for impact of the calibration. So this is the end of my presentation. So thank you for your attention.